However, it has two icy poles. How does that work?
Yes, exactly. So one of the main engineering challenges is to overcome the temperatures on Mercury. One side of the planet, as you mentioned, is well over 400 degrees Celsius. The other side is at minus 180 degrees. And as our spacecraft orbits, it goes from one to the other in a few tens of minutes. So that's a massive constraint for us. In terms of the ice, yeah, this is an incredible discovery that was made recently. We found that buried deep in craters near the poles of the planet, there is solid water ice, which is extremely surprising given the temperatures on Mercury.
So let's talk about exactly what happens over the next 7 years. It takes 7 years for this craft to get there. What happens on the way? Will we get data while it's on its way there? And what happens once it gets there?
Well, actually, what we launched today was sort of four pieces. We launched the Mercury Transfer Module. The goal of that is to get the spacecraft to Mercury. Then we have our two spacecraft that are launched together combined with a sun shield. Now, it's a 7-year journey. And so first we'll fly past the Earth, and then we'll fly past Venus twice, and then past Mercury 6 times before we finally get captured into orbit around Mercury. So it's a really long journey for us. Some of our instruments will be switched on. So the magnetic field instrument, for example, will be deployed in about a week and will be switched on for the entire duration. Other instruments, like the one that we built at the university, will not be switched on until we arrive.
Oh, I think it's fascinating. Susie, thank you so much for talking to us. I'm glad you got to see that launch. And I can see you just jumping up and down in your seat. You're still excited. It's brilliant. Thank you so much. Susie Imber, their mission scientist.